Okay, so here's something that kept me up last night. Boston Dynamics just gave their Atlas robot a pair of hands that can literally feel what they're touching. And at the same time, Figure AI dropped a humanoid robot that can wash your dishes, fold your laundry, and plug itself in to charge overnight. Now I know what you're thinking. Yeah, another robot demo. But here's the thing. This isn't about robots doing backflips anymore. This is about robots doing your job or my job. Or maybe both of our jobs. And look, I'm not here to be all doom and gloom about it, but I'm also not going to sugarcoat it. We're at this weird inflection point where the tech is finally catching up to the hype, and honestly, I'm not sure we're ready for what comes next, so let's break this down. And I mean really break it down, not just the cool tech specs, but the stuff nobody wants to talk about, like who's actually going to buy these things, what happens to the warehouse workers, and more importantly, can I finally get a robot to do my dishes without it breaking everything in my kitchen? Let's get into it, all right. Let's start with Boston Dynamics because honestly, these guys have been the gold standard for robotics for years. You've seen Atlas, the robot that does parkour and backflips and makes you question your own athletic abilities. But here's what's different now. They stopped focusing on making Atlas move better and started focusing on making it manipulate things better. Because here's the reality. A robot that can do a backflip is cool for a YouTube video, but a robot that can pick up irregular objects, adjust its grip in real time and not crush or drop what it's holding, that's actually useful. So they developed this thing called the GR2 gripper, second generation, and this is where it gets interesting. The gripper has 7 degrees of freedom, that's 7 individual actuators. 3 fingers, 2 actuators per finger, that's 6. Plus 1 more for an articulated opposable thumb, and that thumb, that's the game changer. Because without a thumb, you're basically trying to pick things up with chopsticks. With a thumb, you can do 2 finger pinches, 3 finger grasps, and actually stabilize heavier objects by distributing force across multiple contact points. But it's not just about moving parts. Each fingertip has tactile sensors underneath an elastomer surface. So when the robot grabs something, it can actually feel how much pressure it's applying. It's like when you pick up an egg? You don't think about it. You just know how hard to squeeze. That's what this is trying to replicate. They also stuck cameras in the palm of the hand, which is smart. Because sometimes the main cameras on the robot's head can't see what the hands are doing, like when you're reaching into a cabinet or underneath something. Now, mechanically, each gripper is self-contained. All the actuation is inside the module, so you can swap it out if it breaks, and they designed it to be tough. Because robots fall, they trip, they faceplant, and if you've got fragile electronics in the hands, that's a problem. Here's what I find fascinating, though. They debated adding more fingers. 4 fingers, 5 fingers, make it more human-like. But they decided against it, and the reasoning is pretty solid. More fingers means more complexity, more failure points, higher costs, slower development cycles. So 3 fingers plus a thumb is the sweet spot for now. Gets you like 90% of the manipulation capability at maybe 60% of the complexity. And honestly, I think they're right, because the goal here isn't to perfectly replicate a human hand. The goal is to build something that's good enough to be useful in real-world applications. Now let's talk about Figure AI, because they're coming at this from a completely different angle. Boston Dynamics is this legacy robotics company that's been around forever. Figure AI is like they're the startup. They're moving fast. They're trying to commercialize quickly, and they're not afraid to make bold claims. Their new humanoid, the Figure 03, is designed to be a general-purpose robot. Not just for factories or warehouses, but for homes, hotels, retail spaces. Anywhere humans work, they want Figure 03 to work. They're using this in-house AI system called Helix. It's a vision language action model. Basically, the robot can see, understand what it's seeing, and then decide what to do about it. And they claim nothing is teleoperated, which if true is a big deal because a lot of these robot demos, someone's controlling them remotely. This is supposed to be fully autonomous. The hardware improvements are solid too. They made it 9% lighter than the Figure 02. Doesn't sound like much, but when you're trying to move around all day, every bit of weight savings matters. They also got rid of exposed metal parts, added soft washable covers, put padding in pinch points. Because when you're operating around humans, you don't want sharp edges and exposed mechanisms. The camera's got a massive upgrade, 60% wider field of view, double the frame rate, 75% less latency. And they also put cameras in the palms. Same idea as Boston Dynamics on the tactile side. They're using custom sensors in the fingertips. Off-the-shelf sensors apparently weren't good enough, so they built their own. They claim these can detect pressure changes as small as the weight of a paperclip. Whether that's marketing or reality, we'll see. Here are the specs. Stands about 5 or 6, weighs roughly 130 pounds, can carry up to 44 pounds, moves at about 27 miles per hour, battery lasts up to 5 hours, charges wirelessly on floor plates up to 2 kilowatts, and it docks itself, which is actually pretty cool. Now here's where Figure AI gets ambitious. They're gearing their manufacturing for scale. Die casting, injection molding, stamping, basically mass production techniques. They're targeting 12,000 units per year to start, with a goal of 100,000 units in 4 years through their facility in San Jose. And look, that's a bold target. But if they hit it, they've got leverage on costs. Repair networks, supply chain, that's the bet. They're showing demos of the robot doing dishes, working reception desks, navigating stairs, responding to voice commands. But here's my take. We've seen impressive demos before. The real question is, how does it perform when things go wrong? When the layout changes? When there's something unexpected on the floor? When a kid runs past it or a dog starts barking? That's the reality gap. And until we see these robots in actual homes, with actual families doing actual unpredictable day-to-day tasks, I'm keeping my skepticism hat on. So who else is in this race? Because it's not just Boston Dynamics and Figure AI. Tesla's Optimus is probably the most hyped humanoid robot out there. Mostly because it's got Elon's name attached to it. And say what you want about Elon, but the guy knows how to generate buzz. Optimus has shown off some impressive balance and movement capabilities. They've got videos of it walking, navigating obstacles, doing some light manipulation tasks. And the price target Elon's thrown out is around $20,000 to $25,000 once they're in mass production. Now, is that realistic? I don't know. Tesla's been known to miss timelines. But if they can hit that price point, they're going to be extremely competitive. What we don't know yet is how good Optimus is at fine manipulation. The hands look good on paper, but we haven't seen it do the kind of delicate work that GR2 can do. That's going to be the key differentiator. Then you've got Unitree, which is this Chinese robotics company. Their G1 model is known for this anti-gravity recovery feature. Basically, if it falls down, it can bounce back up, which sounds gimmicky, but actually, that's a huge deal for durability and real-world use. And here's the thing about Unitree. They're already selling their robots. The G1 is reportedly going for around $16,000. That's cheaper than what we're expecting from Figure or Tesla. Now, I haven't seen enough about the G1's manipulation capabilities to say if it can compete with GR2 or Figure 03 on dexterity, but on price and availability, they're ahead. Look, here's my honest take on the competition. We're still in the early innings. It's like comparing smartphones in 2008. The iPhone was there. Android was just starting. BlackBerry still thought they were winning 5 years later. The whole landscape had changed right now. Boston Dynamics probably has the best manipulation tech. Figure AI is moving fastest toward commercialization. Tesla has the hype and the manufacturing scale. Unitree has the price advantage, and they're actually shipping who wins. Probably all of them in different segments. Boston Dynamics for high-end industrial, Figure for commercial spaces, Tesla for consumer market, Unitree for budget-conscious businesses. But the real winner is going to be whoever figures out the software first. Because here's the thing. Hardware is getting commoditized. In 5 years, everyone's going to have robots that can walk and grab things. The difference is going to be the AI that decides what to grab and when to grab it. That's why Figure's Helix system is interesting. That's why Tesla's vertical integration with their AI team is dangerous. That's why Boston Dynamics partnering with someone like NVIDIA could be huge. The hardware race is fun to watch, but the AI race is what actually matters. Okay, let's talk about money, because this is where things get real. Nobody's given us official prices yet. But we can make some educated guesses. Figure 3, based on their manufacturing targets and market positioning, is probably going to land somewhere between $60,000 and $100,000 per unit in the first generation. Tesla's targeting $20,000 to $25,000 at scale. Unitree's already at $16,000. For this analysis, let's assume a mid-tier humanoid robot costs about $70,000. Is that a lot? Yes. Is it more than a car? Yes. But here's the comparison that actually matters. A warehouse worker in the US makes about $35,000 a year on average. Add in benefits, payroll taxes, workers' comp insurance. You're looking at $50,000 to $55,000 all-in cost per year. A robot costs $70,000 up front, but it works 24/7. It doesn't need breaks, doesn't call in sick, doesn't need benefits. You've got maintenance costs, let's say $5,000 a year. Electricity, maybe another $1,000. Repairs and unexpected issues, budget another $4,000. So you're looking at $10,000 a year in operating costs. Over 5 years, human worker, $275,000 robot, $70,000 to plus. $50,000 in HR, $120,000. That's $155,000 in savings over 5 years per robot. Now, I want to be really clear about something. I'm not saying this is good. I'm not saying companies should replace humans with robots. I'm saying this is the math that CFOs are doing right now. This is why investment in humanoid robotics has exploded. This is why every major logistics company is running pilot programs. Who's going to buy these first? The first customers aren't going to be regular people. They're going to be businesses with specific pain points. Warehouses and logistics centers are obvious. Amazon, Walmart, FedEx, DHL. These companies move millions of packages a day, and labor is their biggest cost. If they can automate even 20% of their workforce, the savings are massive. Manufacturing is another big one. Assembly lines, quality control, material handling, these are repetitive tasks with clear success metrics. Hospitality is interesting too. Hotels already have labor shortages. A robot that can deliver room service, clean common areas, handle late-night check-ins, that's got real value. But here's what I think is going to be the sleeper market. Small to medium businesses, local restaurants, small retail shops, family-owned warehouses. These are businesses that can't compete on labor costs with big corporations, but they also can't afford to shut down. If a robot drops to $20,000 to $30,000, suddenly it's in reach for a small business owner. That's the price of a used car that's financed over 3 years. That's a business loan territory, and honestly, that's when things get interesting. Because it's one thing for Amazon to replace warehouse workers with robots. That's been happening for years. It's another thing for Main Street businesses to do it. That's a different kind of economic shift. Let's be real about when businesses should actually buy these things. Early adopters are going to pay a premium and deal with bugs. They're essentially beta testing for the rest of us. Unless you've got money to burn or you're truly desperate for labor, you probably wait. The sweet spot is probably 2026 to 2027. By then, the robots will be on their second or third generation. The bugs will be worked out. The prices will have dropped. The software will be better. The support infrastructure will exist for a mid-sized business. I'd say you need to hit ROI within 3 years to make it worth the risk. That means the robot needs to replace about 0.7 full-time employees, accounting for downtime and maintenance. For a large enterprise with multiple locations, the calculus is different. They can absorb the upfront costs. They've got IT teams to manage the systems. And they can negotiate volume discounts. They'll move faster. Here's what I think we're going to see. Nobody's buying these robots outright at first. It's going to be robots as a service. Lease a robot for $2,000 a month. Maintenance included. If it breaks, we replace it. If a newer model comes out, we upgrade you. That's how you get businesses to adopt. Because $70,000 upfront is a big ask, $2,000 a month, that's just another line item in the budget. Figure AI, Tesla, whoever, they're all going to offer leasing and subscription models. They have to. The upfront cost is too high for mass adoption otherwise. And honestly, the RaaS model is better for the manufacturers too. Recurring revenue, ongoing customer relationships, data collection to improve the AI, control over the full life cycle. It's the iPhone model, it works. Okay, let's talk about what these robots actually can and can't do. Because the demos look great, but demos always look great based on what companies are showing us. Here's what seems to actually work. Picking up regular rigid objects, boxes, packages, tools, basic items that works. The robots can do it consistently. Walking on flat, predictable surfaces. Warehouses, factories, clean indoor spaces, that works. Following pre-programmed routines in controlled environments. That works. Basic manipulation tasks with visual feedback. Grabbing a specific item from a shelf, placing it in a bin. That works most of the time. But here's what we know they struggle with. Soft, deformable materials. Try getting a robot to fold a fitted sheet, or pick up a pile of clothes, or handle raw chicken without squishing it. It's really hard, unpredictable environments. A living room with kids' toys everywhere. A kitchen with spills and clutter, a construction site. These robots aren't ready for that yet. Context and common sense. If a robot is carrying a glass of water and someone walks in front of it suddenly, what does it do? Does it stop? Does it try to avoid? Does it put the glass down first? A human knows, a robot maybe? Self-repair. If something breaks, a motor fails, a sensor glitches, the robot can't fix itself. It needs a technician. That's downtime and cost. Social interaction, reading body language, understanding tone, knowing when someone's uncomfortable. Robots are terrible at this. Here's something nobody talks about enough. 5 hours of battery life is terrible. Think about it. A standard work shift is 8 hours. If your robot can only run for 5 hours, you need to swap it out mid-shift. Or have it charge for an hour. Either way, you're losing productivity. And charging infrastructure is a real issue. These wireless charging pads sound cool, but you need them everywhere, in warehouses. That means retrofitting floors. In homes, that means dedicated charging stations. It's not plug and play. Now battery tech is improving. We're seeing new chemistries, better energy density, but we're still years away from all-day battery life in a humanoid robot. There's this thing in robotics called the reality gap. The difference between how a robot performs in a lab versus how it performs in the real world. In a lab, everything is controlled. The lighting is perfect. The floors are clean. The objects are exactly where they're supposed to be. The robot has been practicing this specific task for hours. In the real world, stuff moves around, lighting changes, floors are dirty. Objects are in random places. New situations come up constantly, and that gap is still huge. The demos we're seeing from Figure AI, Boston Dynamics, Tesla, they're impressive, but they're also carefully choreographed. The robot has probably practiced that specific dishwashing routine hundreds of times. The environment is set up exactly right. What happens when the plate is dirty in a different way? When the soap dispenser is empty? When someone moves the dish rack? We don't know yet, and we won't know until these robots are actually deployed in uncontrolled environments. And let's talk about what happens when things go wrong. Because they will go wrong. There was this incident with another humanoid robot where it started flailing during a test. The video went viral. It looked terrifying. And it reminded everyone that these robots are powerful machines. If they lose control, they can hurt people. Boston Dynamics talks a lot about safety protocols, balance recovery, fallback modes, and they're probably the best in the industry at this, but it's still a risk. What happens if a robot is carrying something heavy and its gyros fail? What if it trips on stairs? What if it mistakes a person for an obstacle and tries to push past them? These aren't theoretical questions. These are engineering problems that need to be solved before these robots can safely operate around people. All right, let's talk about the elephant in the room. Jobs? Here's what we know from various studies and projections. Logistics and warehouse work employs about 8 million people in the US right now. Manufacturing is another 12 million. Retail is 16 million. Food service is 12 million. Not all of those jobs are at risk, but a significant portion are. McKinsey estimates that about 375 million workers globally may need to switch occupational categories by 2030 due to automation and AI. That's not all from humanoid robots. That's the broader automation wave. But humanoid robots are part of that. The World Economic Forum says that by 2025, machines will do more work tasks than humans. We're basically at that point now, depending on how you count. Here's my take. The jobs that are most at risk in the next 3 to 5 years are repetitive, physical jobs in controlled environments, warehouse picking and packing, assembly line work, basic cleaning and maintenance, food prep in commercial kitchens. The jobs that are safest in the next 10 years are ones that require creativity, complex problem solving, emotional intelligence, or work in unpredictable environments. Plumbers, electricians, nurses, therapists, teachers, designers, managers. But here's the hard truth. The jobs at risk tend to pay less and require less education. The safe jobs tend to pay more and require more training. That's a recipe for increasing inequality unless we do something about it. I've been reading stories from warehouse workers, and honestly, it's heartbreaking. There's this guy who's been working at an Amazon fulfillment center for 8 years. He's in his mid-40s, high school education. He makes $38,000 a year. He's good at his job, fast, accurate, reliable. And he's watching Amazon test humanoid robots. He knows what that means. He's trying to figure out what he's going to do when they replace him. Retrain for what? He's got a mortgage. He's got kids. He can't go back to school full-time. And even if he could, for what job? Everything he's qualified for is also getting automated. That's the reality we're not talking about enough. Because when we talk about efficiency gains and cost savings, we're talking about real people losing their livelihoods. Now, the counter-argument is that new technologies always create new jobs. The ATM didn't eliminate bank tellers. It changed what they do. Personal computers created entire new industries. And that's true. These humanoid robots will create jobs. Robot technicians, AI trainers, system designers, fleet managers. But here's the problem. Those new jobs don't necessarily go to the same people who lost their jobs. The warehouse worker doesn't automatically become a robot technician. That requires different skills, different training, often different levels of education. So we're going to have this mismatch, jobs disappearing in one sector, jobs appearing in another, but the people aren't moving between them smoothly. So what are governments doing about this? Honestly, not much. There's talk in some European countries about a robot tax. Basically, if you replace a human worker with a robot, you pay a tax equivalent to that worker's payroll taxes. The idea is to slow down adoption and fund retraining programs. I'm mixed on this. On one hand, it makes sense. You're offsetting the social costs of automation. On the other hand, it could just push companies to automate overseas or delay adoption until the tax becomes politically unpopular and gets repealed. Universal basic income keeps coming up in these conversations. Andrew Yang ran a whole presidential campaign on it. The idea is that if robots are doing all the work, we need to give people money just for existing. Again, I'm mixed. I get the logic, but implementation is complicated. How much? Who qualifies? How do you fund it? And more importantly, how do we maintain a sense of purpose and meaning in a world where work isn't necessary? Some places are investing in retraining programs, but let's be honest. Most retraining programs have terrible success rates. You can't just send a 45-year-old warehouse worker to a 6-week coding boot camp and expect them to become a software engineer. We need to be thinking bigger. Career transition support that lasts years, not weeks. Education systems that prepare people for multiple career changes. Social safety nets that actually work. Look, I'm a tech guy. I love this stuff. Watching these robots get better every month is genuinely exciting to me. But I also think we're moving faster than we should. Not because the tech isn't ready, the tech is getting there, but because we as a society aren't ready. We haven't figured out what to do about the jobs problem. We haven't figured out the ethics of robots making life or death decisions. We haven't figured out privacy concerns with robots that have cameras and microphones everywhere. And I'm worried that by the time we figure these things out, it'll be too late. The robots will already be deployed. The jobs will already be gone. The social fabric will already be torn. I'm not saying we should stop development. I'm saying we need to have these conversations now. While we still have time to shape how this technology gets deployed, let's talk about something nobody's addressing. These robots are surveillance devices. Think about it. Figure 03 has multiple cameras, wide field of view, high frame rate, constantly recording. Those cameras are necessary for the robot to navigate and manipulate objects, but they're also capturing everything happening around them. In a warehouse, maybe that's not a big deal, but in a home, in a hotel room, in a hospital, who has access to that footage? Is it stored locally or uploaded to the cloud? How long is it retained? Who can request it? Can law enforcement subpoena it? These aren't theoretical questions. Ring doorbells and Nest cameras have already created privacy controversies. Humanoid robots are going to be way more invasive. And then there's the data question. These robots are learning from their environments. Every task they perform, every mistake they make, every interaction they have, that's data, valuable data. What's a company doing with that data? Are they using it to improve the AI? Selling it to third parties? Training competing products? We don't know because nobody's talking about it. Here's a fun thought experiment. A robot is carrying a tray of dishes. A kid runs in front of it. Does the robot A. stop suddenly and drop the dishes? B. swerve and risk hitting the kid? C. continue forward and bump the kid gently? Different answers are correct in different situations, but who programs that decision? The manufacturer? the owner, the AI itself through learning. This is the robot version of the trolley problem, and we haven't figured it out yet. Or here's another one. A robot is cleaning a hotel room and sees something that looks like drug paraphernalia. Does it? A. Report it to hotel management. B. Report it to police. C. Ignore it and keep cleaning. Again, no clear answer. But someone has to program that decision tree. And speaking of decisions, let's talk about liability. If a robot injures someone, who's responsible? The manufacturer, the owner, the software developer, the AI itself? Current law isn't equipped for this. We've got product liability for defective products. We've got negligence law for human errors. But what about an AI making a decision that seems reasonable based on its training, but results in harm? There's going to be lawsuits. Lots of them. And case law is going to develop over the next decade that defines how we think about robot responsibility. But in the meantime, it's murky. Okay, let's put this all together and talk about what I think actually happens. Right now, we're in the early days. Companies are running small pilot programs, 5 robots here, 10 robots there, seeing what works, what breaks, what the ROI actually is. Prices are high, $60,000 to $150,000 per unit. Only large companies with dedicated budgets can afford to experiment. By the end of 2026, I think we'll have clear data on which use cases actually work. My prediction: warehouse and logistics are going to show strong ROI. Hospitality is going to be mixed. Home use is going to be disappointing. This is when things get real. Second and third generation robots hit the market. Prices drop to $40,000 to $80,000. Leasing and RaaS models become standard. Mid-size companies start adopting. You're going to see humanoid robots in regional warehouses, grocery store back rooms, hospital supply chains. Regulations start getting written. OSHA puts out guidelines. Some states pass robot-specific laws. Insurance products emerge. Job displacement starts showing up in employment numbers, not catastrophic but noticeable. Maybe 100,000 to 200,000 jobs affected in the US. By 2030, this stops being novel. Humanoid robots are just part of the landscape. You see them at the airport, in hotels, at warehouses. Prices have dropped to $20,000 to $40,000. Consumer versions get announced. They're not great, but they exist. Early adopters buy them. The rest of us wait. Major workforce transition is underway. Several million jobs have been displaced globally. New jobs have been created. But the net effect is still negative for workers. Social tensions are high. There's political pressure to do something, whether that's UBI, robot taxes, retraining programs, or something else. Something gets implemented. By the mid-2030s, home robots are affordable for middle-class families. $10,000 to $20,000, maybe financed like a car. They're not perfect. They can't do everything. But they can do laundry, dishes, basic cleaning, some meal prep. For busy families, they're worth it. Culturally, we've adjusted. Kids growing up in the 2030s think it's normal to have a robot at home, just like kids today think it's normal to have a smartphone. New careers have emerged that we can't predict yet. Robot supervisor is a common job title. AI behavior analyst is a thing. Human-robot interaction designer is a growing field. Inequality has gotten worse. Unless we did something about it, that's the wild card. How we handle the next 5 to 10 years determines whether this technology lifts everyone up or leaves millions behind. All right, let's make this practical. What should you actually do with this information? First, be honest about your situation. If you're doing repetitive physical work in a controlled environment, your job is at risk within the next 5 years. Not maybe, it is. So what do? Option 1. Learn to work with robots, not against them. Become a robot operator, a technician, a system supervisor. These jobs are going to exist, and they're going to pay better than the jobs being automated. Option 2. Pivot to a job that robots can't do. Trades are solid: plumbing, electrical, HVAC. These require problem-solving in unpredictable environments. Healthcare is good too: nursing, physical therapy, mental health. Option 3. Go hard on creative or interpersonal skills: marketing, design, sales, counseling. Robots are terrible at these. Start now. Don't wait until you get laid off. Take night classes, get certifications, build skills while you're still employed. Don't be the first to adopt, but don't be the last either. Let the big companies beta test. Let them figure out what works. Watch their pilot programs. Learn from their mistakes. But once the technology stabilizes, probably 2026 or 2027, start planning your transition. Because if your competitors adopt and you don't, you're going to be at a cost disadvantage. Run the ROI calculation carefully. Factor in downtime, maintenance, training, infrastructure. Don't just look at the sticker price and think about the human side. How do you manage the transition? Can you retrain current employees for new roles? Can you do it gradually? The companies that handle this thoughtfully are going to retain institutional knowledge and avoid PR nightmares. Robotics and AI are where you want to be. But be selective. The winners won't necessarily be the hardware companies. It might be the software companies that make the AI work. It might be the infrastructure companies that provide charging networks and maintenance services. It might be the data companies that train the models. Think about the picks and shovels approach. During the gold rush, some miners got rich. But the guys selling pickaxes and shovels? They all got rich. Who's selling the pickaxes in the robot revolution? NVIDIA with their AI chips, companies making sensors and actuators, training data providers, cloud infrastructure. That's where my money would go. You're in the best position. You have time to prepare for the world that's coming. Learn AI and robotics, obviously, but also learn the stuff robots can't do. Creative problem solving, systems thinking, ethics and philosophy, communication and collaboration. The future isn't human or robot, it's human and robot. The valuable skill is knowing how to work with AI and robots to accomplish things neither could do alone. And be flexible. You're probably going to have multiple careers in your lifetime. That's just how it's going to be. Get comfortable with change. So where does this leave us? Look, I'm optimistic about technology. I really am. I think humanoid robots can make our lives better. They can take over the boring, repetitive, dangerous stuff. They can free us to do more creative, fulfilling work. But I'm also realistic. This transition is going to be messy. People are going to get hurt. Jobs are going to disappear. Communities are going to struggle. And whether this technology ends up being a net positive or a net negative for society depends entirely on the choices we make in the next few years. Do we let market forces run wild and deal with the fallout? Or do we proactively shape how this technology gets deployed? Do we invest in retraining and education? Or do we leave displaced workers to figure it out themselves? Do we have serious conversations about privacy, ethics, and liability? Or do we just move fast and break things? I don't have all the answers, nobody does. But I think we need to be asking these questions loudly and publicly. Because the technology is here, it's real, it's happening. Boston Dynamics isn't going to stop improving Atlas. Figure AI isn't going to slow down production. Tesla isn't going to abandon Optimus. The robot revolution is coming. Actually, it's already here. The question is, are we ready for it? Drop your thoughts in the comments. Do you think humanoid robots are going to be a net positive or negative? Would you buy one for your home if you could afford it? What jobs do you think are safe? And if you found this useful, hit that like button and subscribe, because this stuff is moving fast, and we're going to keep covering it. Thanks for watching, and hey, maybe I'll see you in the future, working alongside a robot. Stay curious.